Hi, Ibrahim.
Hello, how about you?
I'm good. How are you?
Fine, thank.
How was your day today? Did you go to school?
Yes,
Wow, you must be so tired now or fresh.
yeah.
When did you come back from school?
Came back 30 minutes ago.
Oh, really?
No, sorry, 1 hour ago.
Did you have some rest?
Yes, I did.
Good. Sona, how about you? Did you also go to school today?
Oh, yes, I did.
Okay. Musa, how about you? I think it's your off day, right, today?
No, like today was like online.
Online. You didn't go to school, right?
Right. It's in the case of like one of our classmates has a virus, and because we must stay at home for 2 weeks.
Really?
Yeah,
What virus? Corona.
yeah.
Oh my gosh. It's a bad news, Musa. Okay. Guys, good to see you again. If you are so tired, put some drink on your table. Okay, when you feel sleepy, just sip, drink some. Okay, so you don't fall asleep. Or all right. So as you remember, actually, we were practicing these questions, and well, let's finish this today, and we will see if we have time. We will see start a new paper. Otherwise, and okay, depends on what can we do. Okay. So we stopped here, and some questions are really interesting. And today is March 3. All right. So, guys, if you're ready, let's start. Okay, we have only like 1 hour, even less than 1 hour left now. And Sona, can you read the question and tell me your idea? What do you think? How do we solve this question?
Okay, sure. A circle and a uh, quadrilateral are drawn on a flat surface. What is the biggest number of regions that can be formed on the surface? Um, is it like 12?
12? How did you get it? 12? You're just guessing?
Yeah, but that looks the most logical one to me. Or
12 is.
like no, 10 makes more sense actually, but like
So you're just guessing. Why? How actually? But can you explain how do you get 10 or 12 or whatever you're saying? Suppose that here we have a circle, right? It is on a surface. It says on a flat surface. Okay, we are on a flat surface. Now you need to draw a quadrilateral, right? So that you can just divide this region into maximum number of smaller regions.
I mean, we can do any number to it. Like, I think any. I mean, but if we're taking quadrat, then I'm not sure.
Ibrahim, how about you? What do you think?
I'm not sure as well.
Okay, good luck. Look, first we need to draw a circle, and after that we can draw a quadrilateral, right? And it says the question here is flat surface, the one keyword here. What is the biggest number of regions? What kind of region? It doesn't matter. The size and nothing is told about the region, right? So it can be any region of any size. It can be
Is it
formed on the surface.
14?
Is it what?
14. Because, like, we can, if it's any size and any, like, kind of shape, we would say, I think, like, there could fit, like, any possible number. And the largest one is 14.
Well, 14, how can we make 14? But can try on the paper, you cannot make 14 different regions. Not different, actually 14 regions. It's
But
not
why
possible.
not? But we can fit them in there somehow.
How? How?
Uh, wait, let me try.
If you can get actually 14, Sona, I will give you a gold medal now. Musa, are you there? What happened to you? Internet connection problem?
Yeah, my computer has problem and then I connected from my iPad.
Hmm.
Oh, I couldn't do it actually. It doesn't work.
Yeah, making 14 is not easy, Sona. I think even it's
14
not
is
possible.
too much.
Yeah. But even I wonder, Sona, can you actually get 12 regions?
I don't think so. After trying it for 14, I don't think I can get 12. Is
Hmm.
it possible?
Yeah, even 8 12 is not possible. Okay. Now, guys, actually one important point here. That's why I'm going to show
Yes,
this.
it's 12.
So, what? 12?
Like the question says like the how to say figures should be equal or what?
No, it doesn't matter.
Yeah, 12.
How is it possible 12? Can you get 12?
Like how to say
No, it's not possible. Look, if I just draw like this, what is this?
like this?
No. It says quadrilateral here. It must be a quadrilateral, right? It's not any line. It's quadrilateral, a circle and quadrilateral. Okay, you are given a lot of quadrilaterals of different shapes and circle. But just actually, if you're allowed to draw any circle, any quadrilateral, the question is, what is the maximum number of regions you can make or you can form on the surface? So now if I draw this, just one important point I'm going to show you here, okay? The first region is, as you see, it is this. The second one is this. Third one is this. Number 4 is this. Number 5 is this. Number 6 is this. Number 7, number 8. And number 10 inside this region, right? Also, this another region. And what is number 10, Sona? Number 10 is outside the whole region. That is here. Okay, as you see here, that's our, actually, just think about this computer screen, all right? The whole thing. How many regions? The outside, the biggest region, 1, right? And the smaller region. So altogether, how many? We have 10 regions here, maximum. We cannot make more than 10. Okay, Musa, did you understand this point? This point is outside the point. That is the important point. A lot of the students cannot see this, and even they don't understand what we are talking about here. That's why it's saying that is a kind of, what is it, hooky question. Actually, this is a tricky question. The biggest number of regions, right? It says regions here that can be formed. What kind of region? How big is it? There's no information about this. It means that it can be of any size. So also the outside this region also is another region, right? Okay, that's it. Let's continue. Another question. Musa, read the question.
70 cakes are packed in 2 different box sizes. And the small box holds 6 cakes and the big box holds 8 cakes. If more than 10 boxes are used and all the boxes are fully packed, how many small boxes are used?
What do you think?
I'm thinking. Mhm.
Hello, teacher.
Hi, Defna.
Teacher, sorry for being late. I was trying to join.
What? You have internet connection problem?
Yeah, like I have a lot of everything. Like I tried to join from my tablet, but like it ran out of battery since I was using it all day long. And then when I tried to open like my computer, it just took a lot of time because it's a little old. And then
It
the
is old.
internet was lagging. I mean, it's not old. It's supposed to be working. It's not like new. Like we bought it 1.5 years ago or something. And it should work for like 5 years without, needing to change it, but it doesn't.
I see. Okay, we definitely just started and we are solving questions. That's our maybe second or third question. Sona, Musa, Defna, here, how you should understand. First, actually, the most important thing is understanding the problem. Number two is in a systematic way, mathematically, how do you solve this? And suppose that we have B, big boxes, and the number of small boxes is S. And each big box can take 8 cakes, right? And the small one can take 6 cakes. In the question, it says that 70 cakes are packed in 2 different box sizes. Okay, altogether, how many? 70, right? And also it says that if more than 10 boxes are used, what does it mean? It means that the number of small boxes and big boxes, it is greater than 10, right? So now we know that actually to find this one, for example, if I can just take this to the right-hand side, is from this equation, well, from this equation, what is S? We need to find S, right? How many small boxes? S equals 70 minus 8 times B over 6, right? So actually, that 70 minus 8B must be divisible by 6. Now, as you see here, for example, if B is equal to 1, what is it here? 70 minus 8, it is 62. 62 is not divisible by 6.
5,
So this B cannot be equal to 1. And how about
5,
if B is equal to 2? It is 16. 70 minus 16, it is 54. That's equal to 9, right? So if it is 9, so this S is, what is it? 9. B is equal to 2. And 9 plus 2, it is greater than 10. So that's the answer. So what is it? It is 9. Musa, did you say 9?
no, I say 5
5? How can it be 5?
because like 6 multiplied by 5 is 13, 8 multiplied by 5 is 14, and 13 plus 14 is equal to 17.
But Musa, also here, we have one more condition here. The number of small boxes and the big boxes, it is greater than 10. If it is 5, 5 plus 5 will be equal to 10. It's not greater than 10.
Yeah, and I understand. Thank you.
Because it says that if more than 10 boxes are used, that's why it should be more than 10. So that's why also that's 1 because of this condition. That's not the answer. That's why it is 9. Okay. And Sona, you should answer this question. Daphne, this is a bit tricky question, but we are not sure. Let's see how you solve this question. Okay. Daphne, can you read the problem and let's discuss this?
Did I read it?
Yes.
Jane is at a road junction with 4 possible roads to her friend's house, but she did not know which road to take. So she asked some passerby for direction. First passerby, your friend's house is not on road 2. Second passerby, I did not want to live near your friend, so I moved to road 2 to road 4. Third passerby, I had taken road to the beach before, but I have not passed any house. Fourth passerby, your friend stays on road 3. If only one of the passerby is telling the truth, on which road Jane's friends live? On which road does Jane's friend live? I have done questions like this, teacher. So we have to like firstly take the one, like write it there. Like the first passerby says that your friend's house is on road 1. And the second one says 2. And the third one says there's nothing in 2. In the fourth one, it says 3.
So Musa, you are saying row 3. Why, Musa?
Because like one say I don't want to live near friends, so I moved to road 2, from 2 to 4, and like if my friend didn't live in first road, in second, in first, and
That's correct.
only 3 is remains.
No, it's not like that. It's like this, teacher. Let's say like the fourth passerby is saying correct way, or like just third passerby is saying it correctly.
No, it's saying that
Then-
if only one of the passerby is telling the truth, that means that others are not telling the truth.
Ah,
So like if it's that, and if she's like staying at the road 3, then third passerby would have said the right thing. And also fourth passerby. We have
Okay, now
to
let's
find
just read one by
a way
one.
just
Then
for one person.
after that, let's discuss and continue. Okay, it says the first one says that this number 1, 2, 3, 4. Okay, just numbered like this. If your friend's house is not on road 1, what is he trying to say here? He's saying that maybe his house is maybe in road 2 or road 3 or road 4, right? We can get it if he's telling the truth. Okay, if he's lying, it means that his road is 1. Okay, now the second one, I did not want to live near your friend, so I moved from road 2 to road 4. So that means that if he's telling the truth, actually, what he's trying to say here, she's trying to say here that your house is in road 2, if he's telling the truth. And the third one is, I have taken road 2 to the beach, but I have not passed by any house. And he's saying that he's not living on road 2, right? So not living on road 2, that means that maybe he's living in road 1 and road 3 and road 4. And the last one is saying that your friend stays on road 3. Okay. For example, let's say if number 1 is lying. If it is lying, that means that he must be living in 1, right? And the second one is lying. That means that he's not living on road 2. Maybe it is road 1, 3, or 4. And if 3 is lying, he must be living in road 2. So if 4 is lying, it is 1, 2, and 4. Then how about, let's say if one of them is telling the truth. Suppose that actually the last one is telling the truth, right? It says that your friend is living on road 3. So what does it mean? It means that others are lying. Is it true then? It's so confusing, but
No, teacher, that's wrong. Then like third passerby would be right. Kinda. If there's like no house at road 2, that means like that person cannot be on road 2. Like so you sort of kind of say it's also correct.
okay, I think okay. Let's say just how about if I just think like this? Suppose that 1, 2, 3 is lying. 1, 2, 3 is lying. and only 4 is telling the truth. Will it be correct or not? If 1 is lying, that means that his friend is living in row 1, right? Can we say that? Row 1.
Mm,
If the second one is lying, that means that his friend is living in row 2. If the third one is lying, that means that his friend must be living in row 2. And if it is living 3, right, telling the truth, that will be okay. There's no contradiction, right? If we just assume like this. Okay. All right. I think row 3. Guys, let's skip this question and think about this. And I think we need to have some brainstorming over this question. And it should be row 3, but I don't know how to prove this. What I feel, but I'm not 100% sure. Because we have to prove that actually when R1, R2, R3 is lying and R4 is telling the truth, there shouldn't be any contradiction here, right? Okay. Okay, just keep in mind, okay, if you have any different solution, let's discuss this. Because if we just talk, I think it's going to take more time. And when we have free time and we just lying down in bed, or when we have free time, let's think about this. Okay. Another question. Musa, can you read the problem?
Elsie has 20 pens. She divides them into 4 piles, so that
Piles.
each
4
piles,
piles.
so that 4 piles, so that each pile has a different number of pens. Find the smallest possible number of pens in the biggest pile.
Okay. So it says that she divides them into 4 piles so that each pile has a different number of pens. And find the smallest possible number of pens in the biggest pile. And suppose that we are just actually putting this file, A is greater than B is greater than C is greater than D. Okay. And now we have these piles, right? And we have just possibilities here. So find the smallest possible number of pens in the biggest pile. In the biggest pile means since they are different, right? This D, it should be 1, and it should be 2, it should be 3, and it should be 4. This A, 4, can it be 4? No, it cannot be 4 if they're different, right? So this A cannot be 4. And how about if it is 5? For example, if it is 5, also 4 numbers, actually, if it is 555, it should be, let's say, for example, the smallest one is 5. Since we are talking about 20 pence, right? Also, this should be 5, this should be 5, this should be 5, right? But that is not possible. And how about if I just take 1 from here and put into the biggest one? At the time here we have 6, and here we have 5, here we have 5, now I have here 4. So again, it says that they are different. Also, these two numbers cannot be the same, right? Now, how about if I take actually, uh, what is it? 1 from here and give this to the first one again. At the time, this will be 7, this will be 5, this will be 4, and this will be 4, right? So still they are the same. Now, how about if I take 1 from here and give to the last one? At that time, they will be different. So here we'll have 8, this will be 5, this will be 4, this will be 3. So the minimum possible number that actually the biggest pile can contain is 8. It cannot contain less than 8 pence if actually, what is it? All of the piles contain different number of pencils. Do you agree, Miss with me, Miss
Yeah,
Daphne, Joe, Musa, and Sona?
yeah, I agree.
Good. So the answer is 8. Good. All right. Sona, you answered this question. Very easy question. Read the question and tell us what is the answer or how do you solve it?
Should I read out loud?
Yes. First read it, explain, after that solve it for us.
Okay. Anna thinks of 7 different positive integers. None of the integers is a multiple of each other. What's the least number sum possible sum of these two integers?
7 integers. What is saying? What number should we start, Sona? What is the smallest possible number here?
0.
No, it is positive integer, right?
Oh, yeah. So like 1 and then
But here also we cannot start with 1 because in the question it says none of the integers is a multiple of each other. And every number is a multiple of 1, right? Because for example, 7, I can write as 7 times 1. That means that 7 is a multiple of 1. So it cannot be 1. So the smallest number should be 2.
2, a
Next
3,
small
5.
2, 3, and 5. 4 cannot because 4 is a multiple of 2. And next
Yeah.
number is 7. 8 is a multiple of 4, also 2. It cannot
10.
be. 10. No,
Yeah,
10 is
11.
multiple of 5.
Oh yeah, 11.
11.
13.
13.
16.
No,
17.
17. But instead, how about if I don't take this? What is the sum here? Let me just calculate this. It is 5, 10, 17, 28, 41, 58, right? Now, how about if I start with 3? Look, if I start with 3, because of this 2, I cannot take any, what is it, even number, right? If I start with 3, at that time, next number will be 4, because 4 is not a multiple of 3. Next number will be 5. 6 is, what's going on here? 6 is a multiple of 3. I cannot take the 6. And how about 7? And also 8, I cannot. 9, I cannot. 10, I cannot. 11. Yes, 11. And 13. And 17, right? So it will be greater than 7, 12, 19, 30, 30. Okay, no.
But it asks for the least possible one.
Yes, the least, I think that is 58. Okay, that's it. All right. Musa, read the question. It's also a very easy question. Of course, if you know the
The
formula.
diagram shows a square. The diagram shows a square, equilateral triangle, and parts of regular polygon. How many sides does the latter polygon have?
Okay. So it says number 1 here, the keywords are, it says number 1, square and equilateral triangle. What do we mean? Actually, what we should understand from here. Since it's a square, this angle should be 90 degrees. Since it is equilateral triangle, right? Actually, the one interior angle is 60 degrees. So that means that actually just one interior angle of this polygon, then what is it? It is 60 plus 90. That is equal to 150 degrees. I mean, that just makes this question more complicated by adding this information, because if you don't know some basic properties of a square, or if you don't know what we mean by equilateral triangle, you cannot answer this question. Okay, now what is it? That is alpha, one interior angle of this, what is it? Regular polygon. And in general, how do you find the sum of the interior angles of any polygon? That is just equal to 180 degrees times n minus 2, right? That is how we find the sum of the interior angles of any polygon. Why? Because we just draw some diagonals. And if, for example, if we are given n-sided polygon, I can have n minus 2 triangles drawing some diagonals. That's why. And the sum of the interior angles of every triangle is 180. And just how many triangles we have inside n minus 2. So that gives us the sum of the interior angles. And how about if you are talking about one angle? If it is regular polygon, all angles are equal, right? So to find one angle, the sum of the interior angles of this polygon and divided by the number of sides of the polygon. That gives us, what is it? One interior angle. Now from this equation, we know the one interior angle, right? That's equal to 150. So that means that this 180 times n minus 2 over n, that is equal to 150 degrees. Now the 0, 0 cancel each other and multiply both sides by n. So here we have 18. Remove the brackets. N minus 18 times 2, 36. On the right hand side, we have 15n. Or take 15n to the left hand side. 18 minus 15, that's equal to 3n. Take 36 to the right hand side, it is 36. Now what is n? N equals 12-sided polygon. So if you are given 12-sided regular polygon, the measure of every interior angle is 150 degrees. So this polygon has 12 sides. Okay.
Okay.
All right. Question 20. Maybe if I give you some time, you may try and can do this, but now instead, let's just discuss together and do this question. Okay, Musa, can you read the question once again?
In the figure below, the ratio of the area of ABC to the area of ADE to the area of AFG is 7, 8, 15. 7 to 8 to 15. Given that one fourth of the area of ADA is shaded, what fraction of this figure is shaded?
Okay. In this kind of questions, actually, it's a ratio problem. Okay. One simple way is let's just label these different areas. Okay. And after that, the question is what fraction of the figure is shaded? We will find this. So here, suppose that this part, actually, how many regions we have here? 4, right? The first part, let me just denote this by X, this region. Okay, the area of the region is X. The second one, shaded region, let's say it is Y. And third one, that is Z. And the last one, let's say it is W. Now looking at this one, it says that the ratio of the area of ABC. What is ABC? It is X plus Y. So here we have X plus Y, right? 2, and the next one, ADE. What is ADE? ADE is Y plus Z. It is Y plus Z. 2, AFG. What is AFG? AFG is Y plus Z plus W, right? That is given as 7 to 8 to 15. Okay. Now from here, since again, after all, at the beginning, we are going to find the what fraction of the figure, right? It's again the ratio. So what fraction of the figure is shaded? That means that here we are going to find this one. What fraction of the figure is shaded means we need to find this y over x plus y plus z plus w. We need to find this, okay? And since it is a ratio, okay, that's why this is the common factor. They cancel each other. Actually, so even I can just assume that this x plus y is equal to 7. After all, they just cancel each other, right? What I'm trying to say here is in ratio, it doesn't mean that x plus y is equal to 7, right? But instead, x plus y is equal to 7p. Y plus z is equal to 8p. And y plus z plus w is equal to 15p. But even if I just take it as p, in the last ratio, p's, they cancel each other. That's why I can just take this without p. So at the time, that means that this x plus y is equal to 7 and y plus z is equal to 8 and y plus z plus w is equal to 15. Okay. Now from here, what is missing here? Here we have x missing here. All right. Now from here, as you see the second equation, y plus z is equal to 8, right? From here, Let me change the color. From here, y plus z is equal to 8. From here, w is equal to 15 minus 8. That's equal to 7. So now we know the value of z, w, sorry. Okay. And also what is given here? It says that 1/4 of the area of ADE, right? And that is the first step, let's say. The second one is 1/4 of the area of ADE. What is ADE? ADE is y plus z. Y plus z is equal to, is shaded. So that is equal to, what's part is shaded? Is just y, right? That's equal to y. From here, if you solve for y, take 4 to the right hand side, 4y minus y. So 3y is equal to z. Okay. So now I know what is how y and z related to each other. Okay, so here we have y, x plus y plus z plus w. It is 15. And what's x? All right, good. So now if I just substitute here, write this equation, and the y plus, what is z? Z equals 3y. That's equal to 8. From here, y is equal to 2. Okay. Now I know y. If I know y from here, then what is x? X is equal to 5. If x equals 5 and the w equals 7, right? X equals 5, w is equal to 7, y is equal to 2. And what is left? Z. And what is z? Z is equal to 6. Okay, that's it. So now this ratio is y is equal to 2 over x is equal to 5 plus y is equal to 2 plus z is equal to 6 plus, and w is equal to 7. That's equal to 2 over 7. 7, that's equal to 20. Or that's equal to 1 over 10. Dot, dot, dot. 1/10 of the figure is shaded. Musa, did you get anything? Did you get everything? Or
Yeah, everything is clear.
very good. Sona, any questions?
No.
Okay, if no, how about this question? Sona, Musa, Daphne, can you try this? It's very easy question, but the important thing is, do you understand the problem or not? Okay, you have 2 minutes, and let's discuss this after 2 minutes. Musa, what is the temperature now in Baku?
I don't know because I didn't get out like for 5 or 4 days.
Okay, right now it is 7. Maximum 11, minimum 4. It means that's still cold. In Phnom Penh, right now it is 29. The temperature always is between 25 and 34, you know, here, always.
Yeah, it's really hot there.
Yeah, it is hot. No, if it's only hot, it is okay, but also humid, you know, because it's near the sea and you are sweating a lot. Sona, any answer?
Oh, not yet. Just a sec.
Not yet. Daphne, are you sleeping already?
No, teacher.
Not
But
yet?
I got cut off.
Come on, you should be able to solve this question. It is very easy question. Yeah, Sona, Musa, no answer still.
I'm thinking.
Thinking. Why are thinking? You shouldn't write down and solve it, Musa.
Yeah, I like think while I solve it. Like now I had 14 plus 2x plus 2y.
No, no, actually, did you label? It says in the question, the perimeter of the unshaded rectangle is 42, right? And suppose that this part is unshaded rectangle. Let's say this side length is A, and this side is B. So we're saying that here, the perimeter of this unshaded rectangle, that is 2 times A plus B, that is equal to 42. Or if we divide both sides by 2, here we have A plus B is equal to 21. In the question, the area of the square is 49, right? What is a square? Square is here. This one is the side equals this, equals this, equals this. Since this area is 49, the side length of the square must be 7, right? All sides are 7. If it is 7, also this should be 7. Also this should be 7. Now, how about this side? It is A. How about this side? It is B. Suppose that the area of this rectangle is A, the area of this rectangle is B. What is the question? We need to find the total area of the shaded region, which is equal to A plus B. What is A, capital A? It is width times length. That is 7 times B. And how about the area of B, region B? That is just 7 times A. And 7 is a common factor. It's just equal to A plus B. Equals, we know what is A plus B. That's equal to 21. So that's equal to 7 times 21, which is equal to 149 square centimeters. That's it, Musa. It is so simple, right?
Yeah, I know my mistake. I thought like the perimeter of square and the perimeter of rectangle, the sum of them is 42.
Hmm. No, no, no. It says if the perimeter of the unshaded rectangle is 42. Only what rectangle, because this one is square, right? If they say
Yeah.
actually these two at the time, Musa, they should actually write here rectangles. Okay, they are talking about only one rectangle. That's why it's only the big one. Okay, Sona, read this question.
Okay. Polite numbers are numbers that can be expressed as a sum of two or more consecutive positive integers. Find all the polite numbers that can be expressed as the sum of two consecutive positive integers.
The name is interesting, right, Sona? It says polite numbers. Why polite numbers? Because they know how to share something with each other. Okay, and those shared numbers are consecutive numbers. They are next to each other like friends. Okay, and such numbers are called polite numbers. Okay, like for example 9, I can write it as a sum of two consecutive integers. 4 and 5 are consecutive integers, right? And 2, 3, 4, these are also three consecutive integers. And how about 10, for example? 10, I can write it as 1 plus 2 plus 3 plus 4, right? So that's also polite number. But in the question, what is asking here? It says find all the polite numbers that can be expressed as the sum of two consecutive positive numbers only. Okay. So now if you just write a few numbers, 1, it is not a polite number. 2, it's not a polite number because I cannot write 2 as a sum of two consecutive integers, right? Positive integers. And how about 3? Yes, because 3, I can write it as 1 plus 2. And how about 4? Also, it's not a polite number because I cannot write 4 as a sum of two consecutive positive integers. How about 5? Yes, I can write it as 2
3.
plus 3. How about 6? No,
No,
right? And how about 7? Yes, it is 3 plus 4. And next number will be 9. It is 4 plus 5. Next number is 11. It is 5 plus 6. Hannah, what do you see here? Actually, these are the numbers. Why it is
Odd
3
numbers,
and
all of
5
them.
and 7 and 9 and 11. It continues. Now, what do you think, Sona? How do you describe these numbers? Because they are
They're
infinitely
all
many,
odd
right?
Odd,
numbers.
odd.
Odd numbers, but not including one, right? Also, one is odd number, but it's not a polite number.
Yeah.
So now my answer is, it is 2 times k plus 1, where k is a natural number. Or you can just write like that, where k equals 1, 2, 3. Every number, actually it is in the form of this, right? Is what is it? The polite numbers under this condition. That can be written as a sum of two consecutive positive integers. I think we did this before, right, Musa? Did we do this question or similar question?
Yeah,
What was the
yeah.
answer? Do you remember?
Uh, no, like, but I know method how
What
to
is the
solve
method?
it. Like,
Tell me.
first of all, we solve one squares, two squares, three square, four square, like this, five
So just in a
squares.
systematic way, right? Since the maximum, the biggest square is 5 by 5, the smallest square is 1 by 1. So we need to count these squares. And how many 1 by 1 squares do we have? Here we have
25.
25. But if you just count 2 by 2, let's say that is the center of the 2 by 2 circle. 1, 2, 3, 4. In the same way, if you just move down, right here we have 1, 2, 3, 4. So here we have 4 times 4, it is 16. And how about 3 by 3? 3 by 3, that is the center. 1, 2, 3. I move down. 1, 2, 3. 1, 2, 3, right? And how about this one? It cannot be the center. How many? It is 9. In a similar way, 4 by 4, here we have 4. 5 by 5, it is 1. So if you just sum up all of these numbers, how many? It is 55. Again, Musa, actually, it's on the idea is, you know how to count it in systematic way. They may change a little bit, okay? So you just need to count, like, what is the smallest size square here? What is the biggest size square here? And the squares between these two sides. Count them in a systematic way, add them up. That gives us the total number of squares that we can see here. Okay, we have two more questions. It says that find the last digit of this number. Okay, 1 to the power of 2015, and 2 to the power of 2015, 3 to the power of 2015, and 4, 5, 6, 7, 8, 9, 10 until 10. Okay. So now, what is it? The last digits, right? To find the last digits, we need to actually add the last digits, and the last digit of the sum gives us the last digit. It may be a shorter way. Right now, nothing comes to my mind, but now the simplest way is, how do we do that? We know that actually the last digit of 1 to the power of 2015, right? Uh, 15, that is 1. And how about 2? If you just look at 2, let me just calculate here. 2 to the power of 1, it is 2. 2 squared, it is 4. And the 2 cubed, it is 8. And 2 to the power of 4, it is 16. And 2 to the power of 5, again, it is 2, right? So that means that this 2015, actually, uh, I can just write 2015 is equal to 5 times 2015 is 403, right? So that means that 2 to the power of 2015, that's equal to 2 to the power of 5 and to the power of 403. This 2 to the power of 5 is 32. The last digit is 2 again. And okay, it is 403. 8, 2. How should we continue here? Okay, why am I? Anyway, 2 to the power of 5, it is 2. So it means that 2, let me just write here. Okay, then I'll delete this. 2 to the power of 2015 is equal to 5 and to the power of 403, right? And the last digit of this one is 2. Again, I can just write it as 2 to the power of 403, which is again equal to 4. 400 is, what is it? It is 5 to the power of 80 times 2 cubed. And this one is 2 to the power of 5. Again, it is just the last digit is 2. So here we have not equal actually, 2 to the power of, again, 80 times, here we have 2 cubed, or that's 83. So again, this 80 is 5 times 16, right? That is 2 to the power of 5 and 16. Okay, 16 times 2 cubed. That is actually 15 to the power of 4. That's equal to 16. The last digit is 16. But it's shorter way. How do you find this? I think I better write this as a power of 6. Okay. So let me just write like this, much better. From here, 2 cubed, the last digit is 8, and 2 to the power of 4, the last digit is 6, right? And we know that the powers of 6 is always end with 6. Now here with 2015, that 2 to the power of 2015, and this one is just 4. I can just write it as 2 to the power of 4 times, it is 400, 403 times, here we have 2 to the power of, what is it? It is, what is 503? 503. It is 2012, 3 more. Here we have 3 here. So this one is, what is it? 2 to the power of 4, that is 16. 16 to the power of anything, the last digit is 6. So the last digit of this number is 6. The last digit of this number is 8. 8 times 6 is 48. So the last digit is 8. And how about 3? 3 to the power of 2015. It is just 3 to the power of 4. Again, times 503 times 3 cubed. From here, actually 3 to the power of 4, it is 81. 1 to the power of anything, the last digit is 1. And here we have the last digit is 7. So the last digit should be 7. And how about 4? 4 is, I can just write it as 2 squared to the power of 1007 times 4, right? Because 2 times 1007, 2014, 2014 plus 1 is 2015. And again, we know that 4 squared is 16, and the last digit is 6. Powers of 6 always ends with 6. And 6 times 4 is 24, so the last digit is 4. And how about 5? 5 to the power of 2015. And if it is even, right, it is 5 squared, for example, the last digit is odd. If it is 5 squared, right, it's always the last digit is 5. But I don't know, maybe I should think it's shorter way, but now that is the way that I can think of. If you just continue here, 6 to the power of 2015, all digits are always 6, right? And 7 to the power of 2015, 7 squared, it is 49. And the 49, it is 81 again. So I can just write it as 7 to the power of 4. So here we have 503 times 7 cubed. And 7 to the power of 4, it is 49. 49, and the last digit is 1. 1 to the power of anything, the last digit of this number is 1. And 7 cubed, 7 times 7, 49. 49 times 7, it is 63. So the last digit is 3. And how about 8? 8 to the power of, again, what is it? 2015. So we can just write it as 8 times 8, 64, right? It is 4. So I can just write as 8 to the power of 4 again. Here we have 503 times 8 cubed. 8 to the power 4, right? It is 64, 64, 16. The last digit is 6. And this one is 8 times 8, 64. 4 times 8, it is 32. 2 times 6, 12. So the last digit is 2. And how about 9? 9, 2015. Again, we can just write it as 9 squared to the power of 1007. And here we have one more 9 because 2 times 1007 is 2014 plus 1, 2015. And 9 squared is 81. The last digit is 1. 1 to the power of anything is 1, the last digit. So 1 times 9, the last digit is 9. So now if you just add these numbers, the first one is, we know that 10, the last is 0. It is 1. 1 plus 8, 9. 9 plus 6, 16. 16 plus 4, 20. Okay, the last digit is 0. Now 5. 5 plus 6, 11. 11 plus 3, 14. 14 plus 2, 16. 16 plus 9, it is 25. So the last digit of this number is 5. All right. This 25, it is a cryptography actually. It takes a little bit time. If you have time, try this at home when you have time. It's also kind of mental exercise. Okay, you should just understand this like this. And maybe next time when we have time, we will just solve 2 or 3 these kind of questions. Okay. Another of the famous one is also you can just try this one. Send more money. Here we have plus money. Of course, this one is very famous one. We have solution in the internet, but without looking at the solution first, you should give it a try. Okay. Anyway, Sona, Daphne, Musa, thank you very much. Okay. Have a good night. Okay. That much is enough for today. And have a nice weekend. Also, I will see you next Monday. All right. Guys, if you have any time to do the questions, just let me know if you need any questions to practice. Okay. See you next Monday.
Oh,
Have a nice weekend. Have a good night. Bye bye.
thank
Bye,
you too.
teacher.
Goodbye. Good luck. Bye.
Thank you.
Bye.
Bye bye.